Now let's begin with transaction concurrency control. In transaction concurrency control, what are we going to do is, we are going to define transactions. What is each transaction? And whenever you have multiple transactions, I will define what is transaction. When you have multiple transactions, when they are concurrently executed, then you are going to face some problems. We are going to avoid them. So why we have to execute transactions concurrently? We will see. Example, let's say you have some database something, and these are the variables a comma b comma c. So what is the meaning of database variable is, it may be table, it may be record, or it may be some field value, whatever it is. So we don't bother about it, and at this moment we don't discuss about it. We assume that everything like table, record, or field value, whatever it is, so we denote it by some database variable. So usually you take variables a comma b comma c in that way. Now when you have some collection of database variables, then what is transaction first you should know, then only you understand concurrency. So transaction is nothing but some, usually what you do with your database, you update it, right? And further you read the data and you modify and you update, otherwise directly you modify, correct? So example, you want to read this data a, then we say for that we are doing read of a. Okay, so maybe the data is in disk. If it is in disk, then you will be fetching the data from disk, right? This entire thing is part of read of a. Similarly, once you modify it, how to modify it? So for that we write this kind of instructions, a equal to a plus 50, this kind of thing, depends on your programming language. Then you will be updating that variable's value back, so that is called write of a. So finally you are using read of a to read the variable value, and a equal to a plus 50, this kind of instructions for modifying it, and finally to update it, so we use write of a. This is called transaction. Transaction is nothing but some meaningful instructions, that's it. So logical unit of instructions is called transaction. It is very easy to understand. Now you know what is transaction. Now I teach you what is concurrency. When you have multiple transactions like this, so maybe read of a something, one more thing is a equal to a minus 50, and b write of a, another typical transaction t2. Now let's denote these instructions by i1, i2, i3. Here let me denote these instructions by i4, i5, i6. One problem here is, if you concurrently execute them, what is the meaning of concurrency here is, so maybe this instruction you are executing at 9 o'clock, this is at 10 o'clock, and this is at 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock. Then we say that you are interleaving the transactions. Whenever the interleaving is allowed, then that kind of execution is called concurrency. We know that. I mean, in programming also, multiple programs can be executed under one operating system, right? So there concurrency is possible. So you might have studied these things, right, already. So finally this is about concurrency. So you know what is transaction, you know what is concurrency. In this concurrent world, now we are in concurrent world, we are allowing everything in a concurrent way. In that model, so you are going to face some problems, especially data in database management systems. When you write transactions, if they are executed concurrently, they definitely face some problems. So that problems we are going to discuss, and we are going to find out the solutions. This entire story is nothing but transaction concurrency control. To understand that, so let me first of all define some things like what is schedule and what is transaction. Already I explained what is transaction, so I will teach you what is schedule. After that we will see what is serial schedule, what is serializability, and what is recoverability. After that I will teach you what are the typical problems you have when you have interleaved execution, then how to avoid them. Do you have any mechanism? Yes, we have lot of protocols. One is locking protocol, and we have one more thing, that is timestamp based protocol. And sometimes you get in this scenario, like when you are dealing with the problems, so you get some more problem, they are nothing but deadlock. When you are finding the solutions for concurrency control, that means whenever you execute transactions concurrently, what happens? You get problems. While solving the problems, you get deadlock problem. So I will teach you how to avoid the deadlock, right? So many things are there, so you can't understand in a line, correct? For that we have to start the theory. Let me begin such theory. First of all, for that you should understand what are the problems you face when you execute multiple transactions at a time. So I will show some typical examples, like 2-3 examples, but there may be hundreds of such examples, but I show some very important examples. Okay, once you go through them, you understand that concurrent execution gives you some side effects. We will see that. Let's see this example. So this example is also known as unrepeatable read problem. Why it is unrepeatable read problem? You understand if you understand the problem. So let me take this problem. In that there are two transactions. One transaction is reading some database item 2 times, and in between T2 is writing it. So let's focus on this read of A clearly. What is the meaning of read of A really? So this is your database. We know that in your database we are going to store our whatever the data we have in blocks, correct? So this is the corresponding block where your variable is residing. Okay, so whenever you say this is one program in your computer which want to access this variable A, then for that it has to write some sequence of instructions to fetch this data, right? That entire process is called read of A. Whenever you do read of A, so this program will have a temporary variable A into it. So we are going to read this one, correct? So then only we can do some modifications. What is the purpose of reading? Maybe you want to modify it. Already I told you so many times. So whenever you want to modify some database item, database variable or whatever it is, first of all we have to fetch the data to our local variables, right? Local memory, main memory of course. So after that later we update it, then we again send that updated data back through write of A. Okay, this one. So at this moment this transaction just want to read it, but 2 times. Maybe so this transaction is nothing but a query called like this, select star from EMP. That's it. So that means what? We are simply reading it. So maybe this transaction is reading some database item A 2 times. Such a way it has a program. Then what happens, we'll see. Assume that this database variable A current value is 100. Whenever you do read of A, it takes some time, of course. Now we are not calculating the time. We are focusing on what happens when you do read of A. So this data 100 will be transferred to this one. Okay. So now after that, let's write timelines so that you can understand it clearly. 9 o'clock this instruction has happened. Then at 10 o'clock write of A instruction of T2 has happened. So really some students ask this question. Sir, do we really have this 1 hour delay? Just for imagination. See, if the delay is 1 hour, then it will be easy for us to understand as a human being. So we are not machines to understand the differences in nanoseconds. If I write 9 o'clock, this is 9 o'clock 1 nanosecond, it would be difficult for us to imagine. That's why I'm taking delays as hues, right? 1 hour. That's it. Otherwise, usually it will be 1 nanosecond. Otherwise, less than 1 nanosecond. Otherwise, sometimes millisecond doesn't matter. So now at 10 o'clock this T2 is executing this instruction write of A. I am writing write of A, but what is the program's intention is that program wants to simply update the variables A value to something. Let's say that something is something A equal to 200, whatever it is. This is also known as blind write. So without reading you are writing something, then that is called blind write. Okay, so the write does not depend on the previous value. Whatever it is, it always modifies it to 200. That is what the intention of this write of A. It also takes some time, right? So how to do that? In your main memory buffered, first of all in some local variable A, let's call A, so that everywhere if I take local variable A, it's possible, right? Every program can have variable A. So it will be easy for me to remember the variables. Otherwise, if I write a variable A here variable B, here variable C, unnecessarily, it will be overhead for us, for our brain. That's why for simplicity, I'm assuming that there is a local variable A that is going to have 200 already. Now we are going to transfer that 200 to this one through one system call. Otherwise, we know that, right? So how to transfer the data from here to here? Simple. If you call disk manager, he is going to do that, correct? So that is what the operation. It takes some time, milliseconds. Now at 11 o'clock, this transaction T1 want to read, the same database item one more time. We don't know the reason. Let's assume that it has some reason which is private. So we don't want to discuss about that. Then what happens, we'll see now. Really, if I execute these instructions at 9 o'clock, so you are reading it, then you get 100. I am assuming that initially this database item has 100 value. Then when you update this write of A, whenever you do this, really it is executed perfectly by your DBMS. Then the intention of this write operation is updating that to 200, right? So we are expecting, transaction T2 is expecting this. Now see at 11 o'clock. 11 o'clock, if this read of A happens, then what happens? What is the intention of this read of A? Simply reading it, right? Go to the database variable and fetch it. So this time you will be seeing 200, right? So you have only one transaction and you have written in instruction read of A 2 times. Then that transaction should see the same data. So here you are seeing 100, you are seeing 200. So this is actually a problem. The reason, one transaction when multiple times a read instruction it executes, then it should see the same data. I have justification for that. What is that? So we don't bother. I mean, my data should depend on my transactions effect, correct? So that means other transaction, because of other transactions updation, you are seeing the different answer. That should not happen. Next time whenever another program is executed, the update should be seen. But for me, so this read of A, here read of A, I just focus on my transaction. T1 thinks locally. When you think locally, read of A, what is the difference? In between you did not write of A. But still data has been modified by other transaction. So what is my idea is other transaction should not disturb my transaction. That is what the goal of transaction concurrency. So we say that this is actually a problem. When this will be a serious problem is you are doing some reservation. So example, let's say this is IRCTC site. In IRCTC site, this is nothing but number of available seats or whatever it is. So first time you have read that value. So it was showing 100. That means 100 free seats. Now second time you want to, because now this is the time you want to book. First of all you are seeing the data. Next time by seeing the data you are going to book whatever. So that's why you want to read it 2 times. First time it has shown 100. Second time let's say it is showing 0. Then it will be wrong, right? So that will unnecessarily gives you confusion. So initially it has shown 100 free seats. But one more time I repeated the same read, but this time I was seeing 0. So that is one major problem, right? So that's why I want to see always 100 in my entire transaction. So this is called unrepeatable read problem. So your read was not repeatable, correct? So we have to, sometimes you want to avoid. It's up to you, right? So easy to, it's okay for me. If it is okay for you, then that's okay. But if it is not okay for you, then it will be problem for us, right? So that is called unrepeatable read problem, right? We will see one more problem, that is temporary update problem, and we have lost update problem. One by one we'll see. Now we'll see lost update problem. Consider these two transactions T1 comma T2 which are operating on database variable A. So see first of all read of A operation and assume that let's say initial A value is 500. Now whenever this read of A is executed, this 500 will be transferred to local variable A, right? We know that. So let's blindly execute these instructions at 9 o'clock, and this is at 10 o'clock, this is at 11 o'clock, this is at 12 o'clock, and 1 o'clock, 2 o'clock. Let me execute them, you understand the problem. So this instruction is done. Now this one. So we are reading again database variable A at this local variable T2, right? So now this local variable A will get 500. I am using same local variable name. It's okay, right? Because multiple programs can have same variable name. So why I am using the same variable name is so that it represents this variable, right? Now A equal to A plus 100 at 11 o'clock. Because of this local variable A will be updated to 600, but not this database variable. And however, now what I want to say is this transaction T1 is not aware of this updation, correct? Still no problem. Write of A, because of this 12 o'clock instruction, and we are updating that here. Still T1 has not seen it. Now A equal to A plus 200. So now you are taking this old value of this A, which is 500. 500 plus 200, 700. This local variable gets 700. After that we are executing write of A. So because of that this will be updated to 700. What I want to say is Finally, this transaction's effect is nullified. Whatever this transaction has done, that is not at all reflected in the database, correct? No one has seen it. T1 has not seen it, correct? So that's why I can say that the update of T2 finally lost. So how can I justify that it is a problem? I will tell you. Usually whenever you don't understand something, remember one thing, the correct execution will be, usually transaction concurrency is a problem for us, correct? Because of concurrency, you should not get different answers. What are the correct answers? I will tell you. If you execute T1 completely followed by T2, there is no concurrency. So for me, so anything other than concurrency, this is called serial schedule or serial set of execution. So T1 to T2, second one is T2 to T1. When you execute T1 followed by T2, otherwise T2 followed by T1, these are the only potential, otherwise possible correct execution sequences, but not interleaving. Because of interleaving, what should happen is the result should be a result of T1 followed by T2 or T2 followed by T1. Then only we say that such kind of concurrency doesn't have any problem. Now we will execute these instructions in a T1 followed by T2 way and second one T2 followed by T1 way, and we'll see this database result. First of all, we'll try to execute T1 followed by T2. Then what could be the output at A? Initially A value is 500, right? I execute entire T1, no concurrency. Read of A. Take the value and increment it by 200 and update it back. Then it will become 700. Then if you execute T2, then T2 will see this result. That means T2 will consider T1's updation, and on that it is going, on top of that it is going to add 100. So easily we can understand that T2 takes 700 and A equal to A plus 100, 800, and update it back, then this will become 800. One potential answer, otherwise correct answer is 800. Then what if I do T2 followed by T1 for database variable A? We will see initially it is 500. Now execute entire T2, read it 500, update, increment it 600, update it. So this will be 600. Now execute T1. If you do that, now this T2's updation will be taken by T1. In that way, either T1 will see T2's value, otherwise T2 will take T1's value. Correct? So if T1 is executed later, then T1 takes updated value which is 600. On that 600 we are going to do plus 200, which will become 800. Anyhow, what I want to say is T1 is adding 200 and T2 is adding 100. Overall, the consistent database value should be 800. Initially your value is 500. These two transactions are executed. Effectively they are adding 100 and 200. Output should be obviously 800. But your output you see now. In this concurrent execution, initially it is 500. Now if I execute 9 o'clock instruction, it was having 500. Then after that 10 o'clock, it was updating that to A plus 100, 600. Then we are updating at 12 o'clock. We are doing this right of A. Because of that, the 600 is updated here. First updation. Then 1 o'clock you are modifying A equal to A plus 200, but not 600 equal to 600 plus 200, because the data which T1 is seeing is 500. 500 plus 200, 700. That 700 will be updated. Correct? 700 is not the correct answer. Always correct answer is 800. So why you got 700? Because of concurrency, which is not correct, right? So finally, if you do the post-mortem, you understand that why you got this problem. T1 was not at all observing this one. T1 took some value. After that, this when entire T2 has been done, then T1 is updating. So this entire updation of T2 has been lost. That's why we say that this is a lost update problem. So we should be careful with, that's why concurrency. Whenever you execute instructions concurrently, there might be problems like lost update problem. Second one, unrepeatable read problem. We have to avoid them. We will see how to avoid them. First of all, you learn what are the typical problems we see because of concurrency, so that you get motivation to learn, concurrency control techniques. Okay, let's see one more problem, that is temporary update problem, also known as dirty read problem. Both are same. What does it mean? To understand it, first you should understand what is abort, what is commit. So first of all, let's start with commit. Commit is an instruction which you can write after the transaction. That means at end of the transaction. Example, let's say take this transaction, reading A, after that incrementing A to 50, after that updating it to that value, permanent value. See, sometimes there will be two perceptions whenever a person writes a transaction, and after that he will have two perceptions. One is he want to make it permanent, otherwise he want to make it temporary. So I can analyze, otherwise I can give an analogy for this one. Example, let's say you are writing a mail to your boss, okay, but you are frustrated at that time. So when you are writing a letter to your boss in a frustrated mood, and after writing this mail, now you are going to send it at that time. So send, second one discard, right? There are two options, you want them, correct? Because you were in maybe in frustrated mood and you have written a letter to boss, and later once you are while writing the message, you slowly your frustration got reduced, otherwise you become cool and you realize that this is not good. Writing this kind of mail to your boss will, so when you do that you might lose your job. That is what later you realized and you thought of discarding it. So I can see this writing the mail as a transaction, now this sending the mail as commit and discarding it as rollback. So finally, so a good design, if really a system is well designed, that should have commit and rollback, right? Similarly, when you write transaction and sometimes you want to see the effect permanently on database, sometimes you want to see the effect temporarily. So after some time, if you feel that this is not good, otherwise you don't want to carry away these instructions permanently, that means you don't want to have any effect, you don't want to have effect on database permanently, then simply write rollback. Otherwise you write commit, that means you know that this series of instructions are perfect and you want to see them on your database permanently. Whatever it happens, anything can happen, but your database result, that means whatever the actions you have performed and you want them to be permanent, then go for commit. So whenever you write a committed transaction, now DBMS will have a greater responsibility, and that responsibility is storing the data permanently. Sir, why are you saying it's a responsibility? So it's quite obvious, right? Like whenever you write, read of A, write of A, then automatically, that DBMS, whatever on which we are writing this transaction, it can easily update the data, right? What's the big deal? There are a lot of problems your DBMS might face. One is, catastrophic failures. Like once you write this transaction and when you ended with commit, once you write this transaction, let's say you submit it, we follow this technique. So whenever you write the transaction, you submit it and DBMS is going to execute that instructions. So writing is different and executing is different. So though you have written a commit transaction, but so far it is not executed by your DBMS. So whenever that transaction is not executed by your DBMS, so DBMS cannot take the responsibility. Remember one thing, DBMS is going to take the responsibility of that commit only after executing the instructions. Similarly, when you write a C program, so don't expect the output unless you execute it, right? So without executing, can you expect the output? No. Writing is different and executing is different. Similarly, let's say you have written this transaction but you have not executed, let's say, then whenever you are executing it, let's say read of A, then this one and this one, then commit. Whenever at any time when your DBMS executes this commit instruction, then DBMS has to store this data permanently. Otherwise, there is no such responsibility. Okay. So if you write commit, then let's say DBMS is storing your data permanently. But what are the problems your DBMS face? I'm going to show. Example, this is, let's say, your DBMS, and you have, let's say, commit is at 9 o'clock is going to be executed. So whenever DBMS executes this one, then that initial value, let's say equal to 50, then your DBMS is updating it to 100. But to update that value to 100, what are the things your DBMS has to do? First of all, this is in your local variable 50, right? So disk has to be prepared and proper location in your disk has to be found, and this 50 plus 50, right? 100. That 100, which is new data, should be stored back to the appropriate location in the disk. For that, lot of instructions your DBMS has to execute. Meanwhile, so many things can happen. Power failure. If power failure happens after your commit, there is a delay, right? Whenever you say commit, Your DBMS has to store it in the permanent database. It takes some time. In between, anything can happen. Power failure can happen, catastrophic failure can happen, that means earthquake, otherwise tsunami. All these things can influence this thing, right? So while your DBMS is storing it back, for that it requires some 10-15 instructions. Meanwhile, anything can happen. Your disk may crash, otherwise power failure may happen, and so many things can happen, and your DBMS may be unable to store it permanently. Think about that kind of possibilities still, but I'm not saying that so in the real world it is happening, but these are all the potential problems. Now current database softwares are dealing this kind of problems. They have lot of good architecture using that, so they are going to do so they are going to recover. This is called recovery. So finally this kind of failures happens, then your the databases are able to recover, right? So that is a different science. We assume that, let's say, recovery is possible at this moment, but at least forget about that area and you just focus. Finally, I can say that whenever I say commit, DBMS has a responsibility to store my data into the database permanently, but DBMS might face lot of problems while doing that. That is not my business. That is called recovery. Of course your DBMS will take care of that, but at any cost your DBMS has to do that. That is what my intention. So that is the meaning of commit. From now onwards, I think in a user perspective, when user writes commit in transaction, the result should be permanent at any cost, right? Remember it. Now we'll see rollback. So rollback is nothing but sometimes you don't want to see that changes permanently. So why that happens, I will tell you. You have written a transaction. The transaction is removing some money from your account. For that, so your condition is like this. You want to do that thing only when you have positive amount. That means your account has at least some money, like 100 rupees or 200. When your account value is 0, then you don't want to do that. Then you will be starting the transaction and maybe you are doing some updations, whatever. That is one typical example, and you are doing some updations. Suddenly you realize that these updations should not be done because some condition what you were expecting, but that did not happen. So based on some conditions, sometimes you want to roll back whatever you did, then you have a provision to do that. For that, simply you write rollback, right? Even in messages also, when you compose a mail and you will write, first of all, once you write the mail, everything, suddenly you feel that it's not good, then you discard, right? So that is the way even this rollback works, like discard. Now what is abort is, sometimes because of some security reasons, because of some transaction concurrency controlling reasons. So to control the concurrency, already we know that we are getting a lot of problems because of concurrency. To avoid that problem, some transactions will be killed, otherwise cancelled. So that is done by actually DBMS. So we say that as abort. So some transactions will be aborted. That is different from rollback. Rollback is it's because of user's intention. Whenever user want to cancel his transaction, we have a command that is rollback. Whenever DBMS want to cancel the transaction, it will cancel it, and the terminology is abort. In that way we use abort, rollback and commit. Now let's try to understand this temporary update problem or dirty read problem with this concept. What is it? Commit, rollback and abort. See this scenario. So transaction T1 is reading some database variable A. Let's say initially its value is 100. Now after that it is updating. In between, see, from now onwards I don't show that arithmetic logic. That means addition, subtractions, whatever. So whenever I do read A, write A, in between we assume that some addition or subtraction, something has happened to your database variable A. Then later we are updating it. Okay, so only this reads and writes we will see, so that the picture will be simple. That's it. That is the only purpose. Now read of A, write of A. Then after that what happened? T2 read from database. Example, initially A value is 100. Now this T1's read and write is updating this to 200, let's say, because of there is one hidden instruction, that is A equal to A plus 100, then it will happen, right? Now if T2 reads here, then it will see a value called 200, correct? So in our discussion from now onwards, I say that T2 is reading from T1. Of course, it is reading from database. But we say that T2 is reading a value which is updated by T1. In short form, sometimes I say T2 is reading from T1. Okay, remember it. Now, this write of A is, because of this write of A, this is going to be modified and it is becoming 300. For that, the hidden instruction may be A equal to A plus 100. Now, after that, let's say this transaction gets committed, then what happens? So, this transaction is expecting its result, whatever it is, 300 should be permanent. So this is what its goal. Like, I don't know whether your DBMS will achieve it or not, but transaction T2 is expecting 300 to be permanent. Okay. After that, see here, abort. What is abort is your DBMS cancel this transaction. What are the reasons? Maybe power failure. Example, power failure occurs here at that time. So there is, that means what? This transaction is in between. Your DBMS has executed only half of the instructions of T1. So we'll see actually typical transaction properties. They are nothing but ACID properties. Then you understand clearly. But at this moment I will tell you, whenever a transaction has been executed by DBMS, and let's write the timings, 9 o'clock, 10 o'clock. Suddenly at 12 o'clock, if power failure occurs, then there is no chance to decide whether T1's instructions, entire things are executed or not, correct? When you are in between, generally what DBMS does is, it will cancel the transaction. Understand my point? The reason at this moment DBMS doesn't have any clue whether still some instructions are going to be executed by this user. Otherwise, this is the end of the transaction. No one knows, correct? In between, because meanwhile power got shut down. So when power failure occurs, then your DBMS generally will cancel this transaction. When this transaction is cancelled, now see the situation of T2. T2 is reading the data from this one, right? So T1, whatever, example C, read of A. So what was the initial value? 100. Then this T1 updated it to 200. But it is temporary because it is going to be cancelled, right? In this scenario, whatever T2 read is, which is 200, which is wrong. First of all, let me mark it. It is called dirty read. Why it is dirty data? The reason, the data which you have taken is not finalized, correct? T1 has not yet decided whether to really permanently store the data or not. Such data you have taken and you are updating. That's fine. Do it. But you said commit. Then now committed transaction usually should be stored permanently. Because of that, now DBMS has a responsibility to update this. Otherwise, so there is a responsibility for DBMS to update the updation of T2 permanently, correct? But what is the problem? Since this transaction got cancelled, this is wrong data, and you took, see here, you read wrong data, and you are asking DBMS to update it. That's a problem. Now DBMS cannot do it. If DBMS permanently stores this to 300, it is doing wrong things. 300 is wrong answer. Why? Because 200 is wrong. Why 200 is wrong? Because that addition is wrong. Why this addition is wrong? Because this transaction got cancelled, right? So that's why I can say that this is a dirty read problem. That's a problem first of all, and I can say temporary update. This update is temporary, and you took it and you did something and you said commit. So now DBMS doesn't have, it cannot, make the changes permanent, but you said commit. So that's a problem. Remember one thing. So whenever you commit, whenever a transaction gets committed, the data should be permanently stored. But now your DBMS has a dilemma situation that it cannot permanently store the result, because the problem is the data which T2 took is dirty. Now this entire thing is inconsistent thing, and we have to commit it, but we cannot commit, right? So that's why. So what is the solution here? The only solution is we have to roll back. So committed transaction has been rolled back. That is dangerous situation. So why it is serious problem, I will tell you. So we can't say already T2 read something, right? See, T2 read it. Now we should say that don't read. How can we say that, right? He already got committed. I will give you one analogy. So maybe let's say you got some lottery. You got some phone call and they said you got lottery of 1 crore prize money. You read it, you understand it, and you started spending it. But you did not get the money so far, but still you started spending. Sir, how can I spend money? Maybe you borrowed from some your friends. You just informed them that I got 1 crore, and you gave lot of parties because in the next week, coming week, you are going to get that prize money. Then with that in mind, you spent all your borrowed money. Then what can happen is that may be fake news, right? This is what like this. So whatever you read is wrong news. Let's say that lottery is not yours, your neighbors. Then whatever you spent, how can you bear it? Now rolling back here means what? How can I roll back? Can I say that can I go to the restaurants and can I say that actually, so this is the story, please give my money back? They don't give because you ate it, right? So similarly here also we cannot do this thing. What is that? When a transaction reads and writes and commits, then later if you want to cancel, that is impossible because this read cannot be, I can say the read cannot be reverted, right? Already read. Example, you read the wrong data. That means you read something which is wrong. Now what can happen is, let's say, can I revert? I mean, how can I rectify this problem? You read already newspaper, and in that some news you have read which is wrong. Now that should be corrected. How can you be corrected? You have to forget about it, right? Whatever the news you read, you have to forget. So it's a very complex thing, correct? Similarly, so whenever you read anything, dirty read or whatever, then the correction will be very difficult, right? That's why I say that in theory, temporary update or dirty read is a problem. Maximum we should avoid it. Understand? Now we'll see one more problem similar to this one. Okay. See one more problem, incorrect summary problem. So why it is incorrect summary problem? You understand if you understand the problem. So read of A. So let's say there are two transactions, and let me explain you what is the scenario. There is one database variable A, another variable B, and they are having some values, and you are going to update some. That means we are going to calculate sum of these two values. Maybe these two are some marks of the student, same student, but this is maths exam 1, this is maths exam 2. Then we are calculating sum of these two exams. Okay. So in that one, so what is happening is T1 is a program. What this program is doing is it is updating every exams marks by 2. See, it is reading A and adding +2, it is reading B and adding +2. That means the student has to get +2 marks, +2 marks. That means 2 more marks in each subject. So finally, if really T1 is executed followed by T2, if this is the serial schedule, then output will be C. T1 followed by T2. If T1 is entirely executed, then A is going to get 12 and B is going to get 22, which would be 34. If T2 is entirely executed followed by T1 without interleaving, then initially we are reading A, reading B, then we are doing sum of A plus B, and we are going to update that sum into this sum variable. Remember one thing, whenever I write right of sum, then into sum variable we are writing some value. And what is that value? Which will be mentioned by this sum. So for semantics, write semantics, this is pseudo instructions. Okay. For write semantics, you should understand it like this: read of A, reading A value 10, read B value 20, and after that sum equal to A plus B. If A is 10 and B is 20, then 10 plus 2 30. Then local variable sum gets 30. And that local variable's value, now write of sum is nothing but we are going to update it this one, but value is taken by this local variable sum. Okay, so these are all just simple instructions. If you really want to write the original instructions, it will be a very long program, but for just understanding what is the problem, we are giving pseudo instructions. If you directly write these instructions in your computer, so do you think they will be executed automatically? No, right? Then why to worry about whether which sum will be updated in which one? So you just understand it, that's enough, right? So don't go for exact syntax. Now T2 followed by T1, if I execute T2 first, then read A, read B. So A gets 10, B gets 20, of course. After that sum equal to A plus B. So 10 plus 12, 20, 30. Then write that 30 into sum, then this will get 30, right? Sum of these two, that's it, very simple program. So output will be 30. How to understand this T2 followed by T1? I can understand T2 followed by T1 like this. So First of all, old sum is calculated. T2 means calculating sum, right? Sum is calculated, then after that values got updated. That's why this sum represents old sum. Perfect, no problem. But if how to understand T1 followed by T2? 34 means first of all values got updated, after that sum has been calculated. Still it is meaningful for me. But you see this interleaving. Because of this interleaving, what happens we will see now. First read A. Into local variable A we get 10, then A equal to A plus 2, it will become 12, but here it is not updated so far, but right of A is updating it, that will become 12. Then this entire program got executed. We know what happens if we execute this one. A will be read, B will be read, right? A value 12, B value 20 into local variables AB. After that sum, which is local variable, which is nothing but A plus B, 20 plus 12, 32. Then write of sum, take 32 and write into sum, this will become 32. So finally if you see, after this set of instructions, sum value is 32, but total execution is not done, right? Still there are some instructions. Read of B, B equal to B plus 2, write of B. Let's execute. If I execute read of B, then it is 20, so B is going to get 20, right? After that B equal to B plus 2, then B will become 22, then update it, then it will be updated. So values got rightly updated, but some value is wrongly updated, right? The reason right? In between, that means, so in between T1 you came and you just took the one old value and one new value. That's a problem, correct? So this problem is called incorrect summary problem. Your summary is wrong, the reason interleaving. Understand this pattern. There are so many such patterns. Finally, what is our goal? I will tell you. Our goal is somehow we have to group the transactions into two parts, good and bad. That's it. So this is for me bad, because it is, of course, it's not because of concurrency. It is of course concurrent. I want concurrent instructions, concurrent execution, but because of concurrency I should not get that side effects or wrong answers. That's why such kind of problems are called bad problems, and good problems are all serial executions are good. Apart from that, there are some interleavings which might not give you that side effects, right? Like this. So they are also good. Now finally I want to separate them into good and bad using some mechanism. How do you, without execution, can we say that this is good or bad so far? No, right? Slowly we are understanding that. Then after executing only we are understanding that something is good or bad, correct? There are some transactions after interleaving also they give correct answer. Only few will give wrong answers. We have to separate them. Think about it. That's why transaction concurrency control comes into the picture. Now we are going to study some mechanisms. If you follow, then you can avoid this kind of concurrency problems. For that we are going to study a concept called serializability, conflict serializability, view serializability. Later we are going to implement some of the techniques. They are nothing but 2PL protocols, that means locking protocols, and timestamp based protocols. All these things are related to this classification, how to avoid the problems, otherwise how to find out a good one and bad one. Okay.